I'm Beth from My Tutoring Bee, and in this video we're going to be going over how to find the missing side lengths of similar figures. I've got a few examples, so let's go ahead and get started. Alright, with similar figures we are using proportions. So if you haven't already, check out my previous video that I posted just before this, and that goes over what proportions are and how we use them to solve for various things such as similar figures like we're going to do in this video. So we've got two trapezoids below our similar figures. Find the missing side lengths. So something that I want to point out is that the angles in similar figures will always be congruent. So this can really help you identify which sides are similar to each other in each polygon based on their angles. So let's start off by taking a look at our two trapezoids here. So we've got a trapezoid with all four sides identified with their side lengths. And then in this smaller trapezoid, we only have one side length that we are given any information about. We need to find the other three. So let's start with that one side of that trapezoid. So we need to use that side and figure out which side of this first larger trapezoid is similar to that. And we can use the angles to help us with that. So I can see that this 4.8 centimeter side length is between the angle that has the two arcs and the one arc. So then when I look over here at this one, even though this trapezoid has been flipped and rotated, we can see that there's that one arc angle and then the two arc angle. So that means that this side length is going to be similar to the 4.8 side length of the second trapezoid. Now I also like to use a table or like a chart like this. This kind of helps me set up my proportions. So I'm going to call this side A and this side B. And then over here on the sides over here, I'm going to write shape 1 and shape 2. All this does is help us to form our different fractions that are going to be set equal to each other. So we'll call this side A of shape 1, right? This is our first shape, and then this is our first side length that we're talking about. So side A is going to go right here with a 12. All right, and then on shape 2, that same side length that is similar, we're going to call that side A for shape 2. So that's where the 4.8 goes. All right, now we need to find another side length that we can solve for. I want to go ahead and solve for x for this particular problem. We're going to start there. It doesn't really matter which one I start with. I'm going to go ahead and start with x. So the x side length is the side that is between the angle with the one arc and the three arcs. So then when we go over to this trapezoid, I can see that this side length that is 8 centimeters is between the angle that has the one arc and the three arc. That's how those angles really help us identify which sides go together, which sides are similar to each other. So from shape 1, remember this larger trapezoid is our shape 1. So the second side, side B, is where we're going to put our 8. And then our shape 2 here is going to be where we're going to put our x. Okay, so now it's really easy to see how to set up our proportion, how to set up our fractions. So we're going to do 12 over 4.8, and that's going to equal 8 over x. And now just like in the proportions video that I did before, we're going to cross multiply. So we're multiplying 4.8 times 8. So let's go ahead and figure out what that is. 8 times 8 is 64. 8 times 4 is 32, plus 6 more is 38. Don't forget our decimal there, so we get 38.4 equals, and then now we're going to cross multiply the other way. So we get 12x. Okay, now our last step is just to divide by 12 on both sides. 38.4 divided by 12. Okay, so 12 can go into 38 3 times, that's 36. We get 2, drop down our 4. Let's go ahead and bring up our decimal as well. 12 can go into 24 2 times, and that goes in evenly there. So we wind up with 3.2 cm equals x. So we know that this side length is 3.2 cm. Okay, let's try to solve some of the other missing side lengths from this second trapezoid. We've already identified that this x side length is 3.2 centimeters. So now let's start working on y. We're going to try to find the y side length next. So we already know, let me go ahead and re-highlight these two. We already know that the 4.8 and the 12 centimeters are similar side lengths. And I want to use that ratio again with the 12 and the 4.8 rather than using my 3.2 that I found in the last problem that we did. Just because in case I made any kind of little small error or anything, you always want to use the information that you're given if you can, if you have it. So we're going to use those same two sides, and instead of using the chart, I'm going to show you a different way that I like to identify my similar side lengths, just so that you can have some different methods and choose which one you like the best. All right, so what I like to do for this is the 12 and the 4.8 are similar side lengths, so I'm going to put a rectangle around those two. Now, I said that I'm going to be solving for y, so I'm going to go ahead and highlight that side of the trapezoid, and then we need to figure out which side length that matches up with over from our first trapezoid. So again, we can use those angles. The y is between the 90-degree angle and the angle with 3 arcs. So I can see over here that that's going to be this line right here, this side right here. And also we can see that it's the parallel line with the base of these trapezoids as well. It's the parallel line that's opposite of those trapezoids. So now what I'm going to do, I put a rectangle around the 12 and the 4.8. Since the 6 and the y go together, I'm going to use just a different shape. I'm going to use a circle, and I'm going to circle those two amounts. So that kind of tells me when I'm setting up my proportions down here, I'm going to put the two rectangles together and the two circles together. So that is one way that you can set up your proportions. Another way that you can do this is put your two rectangles together in each numerator and then put the two circles together in each denominator. Either way, when you're setting up your proportions, either the two numbers from the same shape need to be together in the same fraction, or the two numbers from the same shape need to be together in the same part of the fractions. So let's go ahead and set it up like this, just so I can show you a slightly different way. I'm going to go ahead and put my 12 and 6 from my first trapezoid. So this is shape 1, and each side A and side B from shape 1. And then I'm going to set up that same proportion here. Since the 12 has the rectangle around it, I'm going to use the 4.8 in the numerator of the second fraction. And then the y goes down here in the denominator. So let's go ahead and do our cross multiplication. So we're doing 6 times 4.8, so 4.8 times 6. So that is 48, 24, 28, and then we've got our decimal. So we've got 28.8 equals, and then we're going to cross multiply this way, 12y. And now we just need to divide by 12 in order to finish solving this. So 28.8 divided by 12. Let's go ahead and bring our decimal up there. 12 can go into 28 twice. That gives us 24. When we subtract, bring down our 8, 12 can go into 48 4 times. So we get y equals 2.4. So we know that this one is 2.4 centimeters. All right, and to finish up our similar figures, finding this last missing side length of z, I gave these two trapezoids names. So sometimes you will be given different polygons that are named by their vertices, and that can also be a way that you can help yourself identify which sides go with each other, which sides are similar to the other one. Let's go over the side length that we've already talked about. So we've already talked about side length DE and MN right here. So look at how these letters are arranged in the names of our trapezoid. DE is the first two letters in this first trapezoid's name, and MN are the first two letters that are in the second trapezoid's name. So that's not a coincidence. That is how we name similar figures. We need to name them in the same order with the vertices in the same order as each other based on their similarities. So since DE and MN are similar side lengths, then those two are going to be in the same positions in those names. Okay, and then we also found side lengths MP and DG, right? That was the X that we solved for in the first problem. So again, take a look at this. So D and G are the first and last letters in the name of the first trapezoid, and then M and P are the first and last letters in the name of the second trapezoid. So again, those two go together. They are similar to each other. We also found OP and FG. And so those two, again, these are the last two letters. FG are the last two letters in the first trapezoid, and OP are the last two letters in the second trapezoid. So we can tell by process of elimination that this side length of Z and a side length of 5 centimeters, those are going to be similar. But just to show that with the naming method that I'm trying to display here, E, F are the middle two letters of the first trapezoid's name, and NO are the middle two letters of the second trapezoid's name. So again, those two are going to be similar to each other. All right, let's go ahead and set up. I'm going to use the 12 and the 4.8 again. And then for the Z and 5 centimeters, I'm going to put a circle around those. So we've got 12 over 4.8 equals, and then since the 12 and the 5 come from the same trapezoid, the 5 needs to be on the top there, and then the Z can be in the denominator. I could have also set this up as 12 over 5 equals 4.8 over Z. That would still give us the same answer. Let's go ahead and cross multiply. So 4.8 times 5. 5 times 8 is 40. 5 times 4 is 20. Plus 4 more is 24. And then our decimal. So we've got 24 equals 12Z. We're going to divide by 12, and this one actually comes out to a whole number. 24 divided by 12 is 2, so 2 equals Z 2 centimeters for that missing side length. Thanks so much for watching. I hope that this was helpful for you. This is part of my pre-algebra series. So if you want more videos that go over the various different skills that you would learn in a pre-algebra class, then check out the link in the description below. Also, let me know what you think, and I'll see you next time.